Yay. Oh, that doesn't look good. Okay, so we're going to do a tool talk on SQLMap. Before I begin, SQLMap is a SQL injection tool, so it's really not for discovering SQL injection flaws, it's more for exploiting them. But before we go down the rabbit hole of how you use this tool and how awesome it is, let's just review what SQL injection is real quick. So SQL injection happens when you are passing manually crafted SQL statements to your database and executing them. So like you have an ID field that's just string concatenated into the database query and executed. Does that make sense? I mean, it's bad. It's not a good thing to do, and it can allow your entire database to be taken over. So tonight we're going to be looking at SQLMap against Damn Vulnerable Web Application. Damn Vulnerable Web Application is just a test application for running tools against it, just to evaluate how those tools work and how to use them. It's exactly what we're doing tonight. That's what it's for, is just demonstration purposes. So one of the modules, I guess, in this DVWA is the SQL injection module. And if you're ever curious to whether or not you have a SQL injection flaw, put a comma or a single quote in and submit the form. If you see something like this, you probably have a SQL injection vulnerability. And of course, when I see one of these in an assessment, my eyes light up and I get really excited. So let's take a look at SQLMap. This is kind of squished. It's just, can everyone see that fairly well? Yeah, I guess that's all right. So this looks terrible. Some of the features of SQLMap are, and I was asked to present on this tonight. I was asked to discuss this point tonight by Nate Suber, who is joining us remotely. SQLMap has the ability to just natively route through Tor. So you can fire up your Tor browser, it starts the SOCKS proxy listening locally, and you just do --Tor at the command line, and all of a sudden all of your SQLMap traffic is routed through the Onion network and comes out an exit node somewhere and hits your target, and they don't have any idea it's you. I'm not going to demonstrate exactly how to do that tonight, but it's really dead simple. It doesn't have a lot of legitimate use cases, but I mean, I guess I could see on an assessment if you're trying to route traffic from an IP. If you get like your primary IP address or your C2 server band or something, you want to route traffic across the globe to get to your target. That makes sense. So let's run some SQLMap runs just to take a look at what kind of results we get back. So to do this, I'm going to need the session identifier out of the cookie from DVWA. This is not cooperating. There we go. So I've just opened the Chrome DevTools, and I'm just browsing looking for the cookie. It's going to be in the request headers. And we got this PHP session ID that I just need to copy and plug into the SQLMap command we're going to run. So to run this, we need to have a URL, which is specified by the -u parameter, and then specify the cookie, which is --cookie, and then fill in this session identifier. Then we really start looking at the arguments that we need to pass. Like the first argument the first scan I would do is like -- current DB to see what database is being used by the web application. So hopefully this will work. Current database DVWA. So that means there's a MySQL instance or a database on the server that's called DVWA. If I wanted to see what user is accessing that database, I just do current-user. Current user root at localhost. So behind the scenes, it's logging all this information to your file system so that if you run it multiple times, the same command multiple times, it'll load the data from cache instead of actually making all the requests again. So when you're actually scanning an application using SQLMap, it'll make thousands and thousands of requests, and they're all malicious requests. So loading data from cache is really effective because you don't want to make thousands and thousands of requests every time in case you accidentally run a command twice. So let's look at a few other commands. We can do -dbs, which will show us all the databases running on the instance. Oops. Let's run that one more time. So you can see at the top, I can't really scroll up, performance schema and sys. Those are two of the built-in MySQL databases that come pre-installed on every MySQL instance. So if we wanted to look at, let's say, like all of the tables on that database, you can see there's a users table. Can I scroll up with this overscan? No. Let's try this. Yeah, here we go. So now we can actually see there's two tables in this in this database, and if we want to drill down even further, we can do -t users --dump. So it just retrieved a bunch of information, and now it's asking me if I want to process the hashes it pulled out of the user table. So you can actually do a little bit of password cracking within SQLMap. I wouldn't recommend it. It's terribly slow, but it kind of segues into our next talk on password cracking. Do you want to crack them by a dictionary-based attack? We'll just run this real quick just to show you how fast it is. So it's really, the data here is not too complicated. Like the passwords are like password and let me in. So it's able to crack these really quickly. In a real scenario, like a real assessment or attack scenario, your users table is going to have tens of thousands, if not hundreds of thousands or millions of records in it. So it's not a smart idea to try to crack that many records and using the SQLMap internal tool. It's much better to use a GPU instance somewhere. But I'll leave that talk for Jared. Let's see. What else can we do? I don't know if I have the server set up to get a shell. Yeah, let's see. I have to look up the command to do that. So there is like a shell feature, SQL shell. That's not what we want. OS pwn, or what is it? OS shell. That's right. Okay, let's try this. Let's just do os-shell. See if this works. Let's do PHP. So we're gonna do the common location one since that might actually work. But you can specify a custom location and everything. You're basically looking for the web root, and if you can find it, or if it's one of the default locations, then sometimes, and you got the right permission, sometimes you can pop a shell off this. Doesn't look like we can though. Okay, yeah, SQL shell lets you execute arbitrary SQL commands. Does not return any output. Interesting. Is it passwords? Yeah, I wasn't paying attention when I did the. You cannot do describe on tables. At least I don't think you can. Let's try it. That doesn't look like it worked. Well, no, you can't do select star. You have to know the name of the fields. At least that's what I was operating under that assumption. Let's see, select star from users. Do what now? Oh, yeah, that's right. So we should probably look at the blind SQL injection functionality too. So there's two types of SQL injection, and one of them is when you get like error output or output from the actual SQL instance, and you can just automatically see what the results are. There's another way of doing it where you use like the sleep function to determine what character is coming next. It takes a lot longer, but it can exploit. You're more likely to find a blind SQL injection flaw in a real-world assessment or application than you are just like a regular raw SQLi flaw. So let's take a look at that. So this web application actually has SQL injection flaws built into it, or SQL injection, blind SQL injection built into it. Let's see. Okay, I think I can just manipulate this. So I think to hit the blind instance, all I have to do is change this to blind, and then we can try something like dash or -d. Well, that doesn't look like it worked either. Maybe my session died. Anyway, SQLMap works against blind SQL injection vulnerabilities as well as normal raw SQL injection vulnerabilities. It's just the blind ones take a lot longer to exploit, and especially if you're dealing with millions of records, it can take a long time. Especially if your network latency is not good, it can take even longer because it's all based upon when it gets responses back from the server after the sleep is done. That's basically my presentation. Does anyone have any questions or comments or want to see anything else that I might have missed? All right.
5-10 minute break.
Yeah.
And then we'll go to the next presentation. All right? Thanks.
Oops.
It's like, look, PC just fine. Your Mac put
Who was this?
Brandon. Not Brandon, but he's like, the PC.
Yeah, there you go.
Oh, yeah.